3.2, multiplying and dividing rational expressions. So let's first talk about regular fractions. So if I had 3/4 and I multiplied it by 8/5, how do you multiply two fractions? No, don't cross. Just straight across. So 3 times 8 is 24. 4 times 5 is 20. Now, does that simplify? What can I take out? I can take out a 4. 24 divided by 4 is 6. 20 divided by 4 is 5. Now, did I need to do that at the end? No. Look at this fraction. If I turn this into one big long fraction and I multiply the top and multiply by the bottom, do you see that something is going to simplify? The 8 and the 4 have common factors. So I can take a 4 out of each of those. The 8 becomes a 2, and the 4 becomes a 1, and 3 times 2 is 6, and 1 times 5 is 5. So I recommend simplifying the fractions in the multiplication stage instead of at the product stage. Okay? So let's say I had 15 over 21 times 6 over 18. Now, I don't want to multiply these together and get huge numbers and then use those huge numbers to create a smaller fraction. So do you see anything on top that will cancel something on the bottom? 6 goes into 18 3 times. And 3 goes into 15 5 times. And then the top will just be 5 times 1, and the bottom will be 21 times 1. You guys understand that? Okay. Now watch this. What happens when we multiply 1/2 and 1/3? I get 1 over 6. Now wait a minute. Doesn't multiplying usually make things bigger? Why is 1/2 times 1/3 equal to a number that's smaller than both of them? It's half of a third. That's a good way to say it. So whenever you multiply by a fraction smaller than 1, your answer is going to get smaller. So if I had a fence that was 4 by 3, then we end up with 12, let's say these are feet squared. Okay? Well, what if I multiply something that is 1/2 times 1/3? Well, half would be that big, and third so that's a 1 by 1 square. I didn't draw it very well, but it's supposed to be a square. And if I take half of the square multiplied by a third of the square, how much area do I end up with? 1/6 of the square. Does that make sense? All right, what if we do division? Yeah, that takes too long. So what if we had 7/15 divided by 21/6? No, that's for adding and subtracting. How do we divide fractions? Well, if I had 6 and I divided it by 2, that's just asking how many 2's are inside 6? 3. Okay. What if I had 6 divided by 1/2? How many 1/2s are there in 6? 12. Okay? And the way you do this is you take this fraction and you flip it upside down and you multiply. 6 times 2 is 12, and 1 times 1 is 1. So anytime you have a fraction divided by a fraction, the method is really simple. You flip this upside down and you change it to a multiply problem. Does anything on top cancel anything on bottom? 7 goes into 21 3 times. Anything else? 3 goes into 6 and 15. So 6 divided by 3 is 2, and 15 divided by 3 is 5. So what's left on top? Okay, 2, and the bottom? 15. You guys understand that? Right there. Okay. Now, we're going to do the same thing, but we are introducing variables. Okay. Actually, let's zoom in a little bit so you guys can see. So, I can just multiply these. And on top, I would get 18b to the third, c to the third. And on bottom, I would get 30 BC. And then I could simplify. What goes into 18 and 30? 6. 2 does work, but 6 is a better option. So 3 and 5. What happens to the b's? So 1 on the bottom cancels 1 on the top. This becomes a 2. And the same with the c's. So in total, I end up with 3b squared c squared over 5. Yes. Okay, now that's not the way I would do it. That takes more thought process and it takes longer. I would just look at this and start canceling things. What there will simplify? Well, this c will cancel that c. This b will turn this b into a 2. 3 goes into 9 3 times. Anything else? 2 goes into 10 5 times. So on top, I'm left with a 2, a b squared, a c squared, and a 3. And that's where 3b squared c squared comes from. On bottom, I'm left with a 1 and a 5. Both ways work. You can either multiply them together and then simplify, or you can simplify and then multiply. Okay. Same thing here, but we learned last time that you are not allowed to cancel a portion of an addition or subtraction. So, oh, this isn't a very good one, but let's say this was an 8. You're not allowed to say 8 cancels 8. Right? You cannot cancel a portion of an addition or a subtraction. You have to cancel the whole thing. So these are a little bit trickier. Can I take anything out of this? Eight. So I pull out an 8. What's left? X plus 7. Okay. Can I take anything out of this? Take out a 4, and I get x plus 7. So I can erase these. Does anything on top cancel anything on bottom? The x plus 7s cancel. Does everybody understand that? You can't just cancel the x and you can't just cancel the 7. You have to get rid of them together as a whole. Anything else? So the 4 goes into 8 twice. In the numerator, I'm left with a 3 times a 2, which is 6. In the denominator, I'm left with 4 times 5, which is 20. Well, no, 1 times 5. There, that makes more sense. 6 over 5. All right. Number 3. Same idea. So, two numbers that multiply to be 2 and add to be 3. X plus 1 and x plus 2. Down here, I can pull out a 3. X minus 2. And then that's an x minus 2. And this one is x plus 2 and x minus 1. Uh-oh, she's on her phone. It's not good. It's okay. First one's free. What cancels? The x plus 2's cancel. And that looks like it's it. So to write your answer, you need to put the x plus 1 on top. And then 3 times x minus 2 and x minus 1. And just leave it in that form. Any questions about that? Yes. So on top there's an x plus 1 and an x plus 2. And on bottom we have an x plus 2. But this one doesn't match up with either of those. Oh, good eye. I forgot that. Yes. Good. Thank you. Okay, good job. I do mean minus 1. There we go. Sorry, those x minus 2's do cancel. I missed it. You should teach the class. Okay. How do we divide two fractions? Flip the second one upside down. Does it matter which one you flip? Yes. If you flip the first one, your answer will be upside down. So 2ax and 3x to the 5th. Then we start canceling. 9 and 3 both share a 3. So a 3 here and a 1. These two x's will turn this 5 into a 3. A cancels A. And 2 goes into 10 5 times. So on top, I'm left with 3 times 1. And on bottom, I'm left with 5 times 1 times x to the 3rd. Like that. Any questions? No? Okay. Flip this upside down. Well, first, I'm going to pull out a 2. Pull out a 2 here. And then pull out a 7 here. Pull out an 8 here. Then I'm going to rewrite it and flip the second one. So x plus 3, 2 times x plus 5, multiplied by 8 times x plus 5, and 7 times x plus 3. What cancels? X plus 3's, x plus 5's, and the 2 goes into 8 4 times. So on top, I'm left with a 4, and on bottom, I'm left with a 7. So the final result is just 4/7. That might be everything. Let me look. Oh, nope, we better do this one. Okay, I need to factor everything. X minus 3, x minus 1, x minus 2, x plus 1, and this one I can take out a 3. So now we need to flip. So the left side is x minus 3 over x minus 2 and x plus 1 times, flip the second one, 3 over x minus 2 over x minus 1. So, wait, did I do something wrong? X minus 2, x plus 1. This is a plus 1. Oh, I'm missing an x minus 1 here. Okay, that makes sense. So, the x minus 2's cancel. The x minus 1's cancel. So on top, I get 3 times x minus 3. And on bottom, I get x plus 1. And that's it. Okay, get to work.